Hello viewers, welcome to Sakin Math Hub, the solution to your math problems. We are still on bearings. We are looking at distance bearing problem. Question 5, I read. A cyclist starts from point A, travels 8 kilometers in the direction 30 degrees to point B. So let's represent this information on a diagram. So we have our solution. So he starts the journey from point A. So this is our point A, and point A, this is our geographical note. And since this is a 3-figure bearing, how do we measure 30 degrees? So we said that for the 3-figure bearings, angles are read from the geographical note in the clockwise direction. So in the clockwise direction, we have to measure 30 degrees. So this angle here measures 30 degrees. So here will be our point. Here will be our point B. Here will be our point B. And what was the distance? So from point A, he traveled 8 kilometers to point B. And then from there, he then traveled 10 kilometers north to C. So this is his current location. So from B, he traveled 10 kilometers north. 10 kilometers north. So there's the direction of the north, and the distance here is 10 kilometers to point C. So what are we looking for? We have to find the cyclist's distance and bearing from A. So this is his destination. So we want his distance from A. So the distance between his destination and the starting point. So we are looking at this distance, line AC. So how then do we calculate line AC? So it becomes very difficult. But can we create a triangle out of line AB? So considering line AB, can we create a triangle? Yes, we should be able to create a triangle. How do we create a triangle? So we can extend this line here. So we see that we are getting a right angle triangle here. Now, when you also take a second look, we see that we have two right angle triangles. We have the bigger right angle triangle. So for the bigger one, I'm naming it as triangle A, C. So I'm naming this point here as D, so that I get triangle ACD. ACD for the bigger one. And then can you also see the smaller right angle triangle? So I'm naming it as triangle, the smaller one, triangle ABD. ABD. So we make references from them. So now, from the smaller right angle triangle, so that is from triangle, the smaller one, ABD. We want to calculate this length here, line BD, and also line AD. That is what we want to do. So even before we do the calculation, at least we need one acute angle inside the smaller right angle triangle. So how then do we do that? We have two ways. We see that this line here This is a parallel line, another parallel line. This line here is creating an angle of 30 degrees. So this 30 degrees angle is alternating with this interior angle here. So that is one way of getting here to be 30 degrees. Or we know that the whole of this is a quadrant, and the total measure of the angle inside the quadrant is 90 degrees. So if this part of the quadrant measures 30 degrees, then this side here must also measure 60 degrees. So now, can we identify the size of the smaller right angle triangle? That is triangle ABD, triangle ABD. So if 60 is the acute angle, then this side becomes the opposite, because it is the side facing 60 degrees. AB, line AB becomes our hypotenuse, because that is the longest side. Again, it is the side facing the 90 degrees angle, so that makes it the hypotenuse. So obviously the remaining side becomes the adjacent. So now we are going to calculate the length of the adjacent as well as the length of the opposite. So let's start with the length of the opposite. So to calculate the length of the opposite using the smaller right angle triangle, we have to consider our opposite. We also know the length of the hypotenuse. We know the length of the hypotenuse. So from SOHCAHTOA, which of them has opposite hypotenuse? So that is SO. And what does SO say? SO says that the sine of the acute angle, in this case 60, should be equal to the length of the opposite. So what is the length of the opposite? So I'm naming the length of the opposite as line DB divided by the length of the hypotenuse. So for the smaller right angle triangle, the length of the hypotenuse measures 8 kilometers. So sine 60 is the same as sine 60 on 1. You can cross multiply. So what is 8 times sine 60? 8 sine 60. And the 1 times dB. That should give us 9 dB. So from our calculator, what is 8 sine 60? So 8 sine 60, 6.022 decimal places, 6 point. Okay, let me make it 6.93. So the length of dB is equal to 6.93 kilometers. So now we know the length of line dB, so the length of the opposite. Again, from the same triangle. So again, from the smaller right angle triangle, that is triangle ABD. Triangle ABD, the smaller one, ABD. This time we want to calculate the length of the adjacent. So to calculate the length of the adjacent, it means that we have to consider our adjacent, and then we also know the length of the hypotenuse. So from SOHCAHTOA, which of them has adjacent and hypotenuse? K. What does K say? K says that the cos of the acute angle, which is 60, must be equal to the length of the adjacent. I'm naming the length of the adjacent as line AD. So line AD divided by the length of the hypotenuse, which is 8 kilometers. So cos 60 is the same as cos 60 over 1. So we can cross multiply. 8 times cos 60. 8 cos 60. And then 1 times line AD. Line AD. So from our calculator, what is 8 cos 60? That is 4. So line AD measures 4 kilometers. So we now know the length of AD as well as the length of DB. So now, let's calculate the length of AC, which also represents the cyclist's distance of his destination from point A. So let's do that. So we could see that for us to calculate this length here, line AC, we have to take into consideration the bigger right angle triangle. So the bigger right angle triangle, remember that we named it as triangle ACD. This one, that is the bigger one. So now, for the bigger right angle triangle, what is the length of AD? So the length of AD has been calculated as 4 kilometers. And what is the length of DC, or in other words, CD? So CD will be 10 kilometers plus line DB, which is 6.93 kilometers. And that should give us 16.93 kilometers. So take notes. So using triangle, the bigger one, triangle ACD, the bigger one, ACD, from Pythagoras theorem. So from Pythagoras theorem, we know that the length of the hypotenuse squared, in this case the length of AC squared, because AC is the hypotenuse, the longest side. So AC squared must be equal to the sum of the squares of the other two sides. So the length of the adjacent, in this case line AD. So line AD we had 4 kilometers, so 4 squared, plus the length of the other side. For the bigger right angle triangle, you want the length BC. So consider that the length DC, consider that DC has been divided into two. One part is line DB. So for line DB, we have 6.93 kilometers. And then the other part is line BC, which measures 10 kilometers. So the full length here becomes 10 kilometers plus 6.93 kilometers. And that should give us 16.93 squared. So AC squared, 4 squared is 16. And then 16.93 all squared, 286.6249. So now, the length of AC squared, so 16 plus 286.6249, so that is 302.6249. We are looking for AC, not AC squared. So we take the square root on both sides. Then the square root and the square will cancel out, leaving AC is equal to, so square root of 2 decimal places, 17.40 kilometers. So that is the distance. That is the distance of the cyclist's destination from A, 17.40 kilometers. So now we are also to calculate the bearing of the cyclist's destination from A. So I'm naming the distance here as A. So the B part, we want the bearing from point A. So how do we calculate that? So from point A, this is his starting point, and this is his destination. So what will be the bearing from A? So bearing from A, we said that we have to read from the geographical north in the clockwise direction until we get to the line that connects point C. So this small acute angle here, so there is theta here, that small acute angle there. So how then do we calculate this acute angle? How then do we calculate this acute angle here? So now let's take note of something. We see that if here is theta, then theta is alternating with this angle here. Theta is alternating with this angle here. So if here is theta, then this angle here must also measure theta. This angle here must also measure theta. So we see that this theta here is located inside the bigger right angle triangle. So from the bigger right angle triangle, so how did we name it? So from triangle ACD. So if this angle here is theta, then the adjacent here, this side here, line AD, becomes the opposite. Take note. Theta, we are making reference to this angle. So if here is theta, then this side here becomes our opposite. This side here becomes our opposite. And then this side here, line CD, becomes our adjacent. So let's take note. We are making reference to this theta. So this length here, line AD, becomes our opposite, and then line CD becomes our adjacent, and line AC is our hypotenuse. So now, using, because we know the length of our opposite now, we know the length of our adjacent. So using opposite and adjacent. So from SOHCAHTOA, we see that TOA has opposite, adjacent. And what does TOA say? TOA says that the tan of this acute angle here should be equal to the length of the opposite. So in this case, line AD becomes our opposite. And what did we get for line AD? We have 4. So the opposite divided by our adjacent. So line CD becomes our adjacent. What did we get for line CD? So line CD is 10 kilometers plus 6.93, and that should give us 16.93. We are looking for theta, so we have to take the tan inverse on both sides. So when you take the tan inverse of tan theta, the tan in its inverse will cancel out, leaving theta is equal to the tan inverse of 4 on 16.93. So from our calculator, what is the tan inverse of 4 on 16.93? So theta is 13.29 degrees. That is 2 decimal places. So that is it, and that is the cyclist, the bearing of the cyclist destination from point A. That is this theta, and theta here is giving us 13.29 degrees. I hope you enjoyed this episode. Thanks for watching.